All right, this is gonna be a fun one. I was going through my notes and I found this note right here from January 14th, 2015, which was from my very first computer science course at ODU. All right, to give you a little bit of backstory here, I didn't go straight from high school to ODU. I went to TCC Community College because I was working a full-time job, and then I took a programming course at a different college. I liked it, and then I transferred over to ODU, where I took a full online semester there because I was still working my big boy job, is what I called it. But since I already had one programming course under my belt, it didn't quite transfer directly because that was Java and ODU C++. So I took this accelerated course, CS333. CS333 there is CS 150 and CS 250 combined, which that is Intro to Programming 1 and Intro to Programming 2. All right, now that you're all up to speed, let's take a look at the few takeaways I had from this very first online conference. So the first thing I wrote down was don't write code without design. Now this isn't hopping into something like Adobe XD and designing what you want the front end of your website to look like. These are software design patterns. One example being top-down design. This is your typical, you have one big project, one big problem that you need to solve, and then you break those down into smaller details, user stories, whatever you want to call them, and then you break those down into even smaller problems, subtasks, basically actionable steps. Whereas top-down design is an extension of stepwise refinement, which, if you can't tell, is a basic technique for low-level design. The idea behind stepwise refinement is that you have pseudocode statements that are repeatedly expanded until we reach a level of detail where the translation into true programming language code is pretty obvious. So you start with a general statement of the problem, you pick any statement whose translation into code is non-obvious, and then you expand that statement into two more steps, and then you continually repeat these steps until all statements can easily be coded. For an example, say you have an auction program where you want to determine the winners of a daily auction. Well, that's our only statement, so let's break that down. So in order to determine that, you need to initialize auction data, you need to determine the winners, you need to clean up. There are many other design patterns. One is actually the opposite of top-down design, which is cleverly called bottom-up design, where you kind of figure out the different attributes in a program, and then you kind of see how they connect in these entities, and then you just try to figure out how these entities all connect and how they're all linked together. But these set of attributes, they're not necessarily related to these set of attributes, but these are related to that entity, and these are related to that entity, which then are related to the big overall program itself. You get the idea. So, takeaway 1, don't write code without design. My next point was keep a log of how I change my code. I have no context here. Remember, this is effectively talking to people with a little bit of programming knowledge. I mean, it could quite literally be a change log. It could be make good notes in version control. There are a lot of different ways to log of how you change your code, but it's good to document how you change your code, which version control is maybe not a substitute for it, but I like that. Keep a log of how you change your code. And then we have a few here that are grades sent to CS email account, okay. DreamSpark account with EDU email. I believe that is called something else now. Microsoft DreamSpark. It's called Microsoft Imagine now instead of Microsoft DreamSpark. And I know I kind of channeled Microsoft in last video, but they do have this Microsoft Imagine where you can log in with your student account if your school provides it, where you can get a lot of these different tools and whatnot for free. Free cloud services, Microsoft Azure, free fully featured IDE, Visual Studio, cross-platform framework, Xamarin. You have free dev training at Pluralsight. You have all of this other stuff. Okay. Y'all can go through this yourselves y'all probably already know about it if you're already in college. If not, it's worth asking your advisor if you have access to this, if any of that is interesting to you. Also, don't forget about, actually, I don't know if I have this written in here, if I'm jumping the gun here, but I know you can have a GitHub, look into the student GitHub stuff. You can get unlimited free private repositories and all that stuff. My knowledge may be a bit outdated. I don't know exactly how it is, especially now that Microsoft owns GitHub, but you get a lot of perks as a computer science student at, typical United States colleges. I don't know about elsewhere. Complete all of 1.1 basics by Friday. I wonder what that entailed. So my very first week, I needed to read the course orientation and intro, which was that, and then, slides. But okay, yeah, see, there's a lot of information in these slides. And this right here, definitely the most critical advice that anyone can ever take is pace yourself. There's a lot of material in this course. There's not time to waste, especially being stuck on an assignment, and future assignments typically build on previous assignments, is what he says here. But so if you get stuck, ask questions. I'm a broken record at this point. If you get stuck, you exhaust all possibilities, ask your professor. That's part of what you're paying for. Oh, and very good advice here. Take the time to frame your question carefully so that I have enough info to actually give you a helpful answer. Pretty solid. And then I had an account set up, and then I had to do logging in stuff. Mind you, this wasn't my exact course. This is open to the public. I had Kennedy, not Zeal, for this class, as well as I did in 2015, not 2017. But this was the first thing that popped up when I typed in CS333 ODU. Roughly 2 hours per exam, and they are online through Blackboard. Remember, this was an online class. Part 1 should be familiar, part 2 and 3 should seem new. That's because this accelerated course, you had to have a little bit of knowledge, and I already took a intro to programming course, so that's what they said. If you already have like an intro to programming course or a little bit under your belt, then part 1 should basically reiterate everything, but in a much smaller time span. But part 2 and 3, that's where you should start seeing new things. I know I just reworded exactly what that meant, but figured I'd elaborate. GUIs are covered in CS330. Go through all tabs on the left of the module. Complete all of CS252 prior to midterms. Incredible advice, because CS252 you had to take, it was a co-requisite is what it's called. You had to take that, and this was Unix. The topics covered were literally working at the command line, the Unix file system, file manipulation commands, editing files in Nano, Emacs, and Vim, file transfer, regular expressions, all that good stuff, program development, so like compilers and stuff, and then working in graphics mode and scripting, like writing shell scripts and stuff like that, customizing the Unix environment. That's where it all started. And a bunch of other random stuff that you can see. But I finish off these notes. The final point that I made is, what is Ubuntu and Solaris? I have come a long way since then. I had no idea what Ubuntu was. There are people talking about, oh yeah, Ubuntu this, Ubuntu that, Solaris this, Solaris that. I think it's because maybe someone brought up Solaris, and then my professor was like, I actually like Ubuntu better, or vice versa. I'm like, I don't even know what the heck you're talking about, so let me write that down. Now that is where it all started. But that's it. That is the end of this little note that I found from January 14th, 2015 from Conference 1 of my CS33 class, my very first real semester computer science, aside from that single coding course that I took a semester prior. And I do have a question for y'all. I went through a little bit based on what I learned on my first day as a computer science student. I went through a little bit of my first programming class as a computer science student. Do y'all want me to make a video just briefly going through everything I learned in that accelerated programming class or not? I don't know if it's going to be interesting. I mean, I think it'll be interesting, and I make videos that I find interesting, but I have a lot of other videos that I also find interesting that I'll be making in the near future. I just curious to see if y'all think this would be a good addition to it. What I learned in my first programming class as a computer science student. Probably won't name it that, but you get the idea. If you like this video, click that like button. Subscribe if you want to see more content like this. This was really just an off the cuff. I saw this morning, but sometimes these off the cuff videos make the best videos. So I hope you enjoyed it again. And I thought I had another note of Conference 2. Maybe it's just on my laptop. I'll have to check. But for this video, I think that's all I have to say on the matter.